In the frozen void of space, 13 billion light years from Earth, something unimaginable is staring back at us. The James Webb Space Telescope has probed deeper into the cosmic abyss than any instrument before it, and what it discovered defies every law of physics we believed we understood. Ancient galaxies that shouldn't exist, black holes older than time itself, and signals from rogue worlds screaming across the emptiness. If you enjoy uncovering the universe's darkest secrets, hit that like button because what I'm about to reveal will change how you perceive reality forever. Prepare yourselves. We begin. Something is profoundly wrong with the universe itself. For decades, scientists assumed they understood how fast our cosmos was expanding. The Hubble Space Telescope provided one measurement. Mathematical models forecasted another. Everything seemed to fit together like pieces of a cosmic puzzle. Then James Webb observed deeper than anyone had ever looked before, and the puzzle shattered into 1,000 fragments. The universe is expanding at two entirely different speeds depending on where you measure it. Think of it like a balloon being inflated. But the top half stretches twice as rapidly as the bottom half. This should be impossible. The laws of physics demand that expansion occurs uniformly across all of space. Webb confirmed what astronomers feared most. When they measured the expansion rate using distant stars called Cepheid variables, they got one figure. When they calculated it using the cosmic microwave background radiation, they got a completely different figure. The discrepancy isn't minor. We're talking about a divergence so massive that it suggests our fundamental understanding of reality is flawed. Scientists call this the Hubble tension. But that term doesn't capture the true horror of what we're facing. This isn't just a measurement error or a calibration issue. After analyzing over 1,000 Cepheid stars across 5 separate galaxies stretching 130 million light-years into space, the contradiction persists. The implications are staggering. Either our models of how the universe functions are entirely broken, or there's some unknown force tearing reality apart. Dark energy, the mysterious substance that drives cosmic expansion, might be acting in ways we never imagined. Some regions of space could be expanding faster than others, creating cosmic rifts that challenge everything we know about space-time. Adam Rees, the lead researcher who discovered this crisis, stated bluntly, with measurement errors ruled out, what remains is the genuine and thrilling possibility that we have fundamentally misunderstood the universe. The word thrilling feels wrong when you consider what this implies. If our basic understanding of cosmic expansion is incorrect, then our calculations about the universe's age, size, and ultimate destiny are all questionable. Webb's unprecedented accuracy has removed any doubt about the measurements. Both the telescope and Hubble are detecting the same impossible contradiction. The universe is expanding, but it's doing so in a manner that violates the laws of physics as we comprehend them. This discovery alone would be enough to shatter cosmology textbooks. But Webb was just getting started. As the telescope continued its survey of deep space, it began detecting objects that shouldn't exist, behaviors that defy explanation, and phenomena that suggest our reality is far stranger and more perilous than we ever imagined. The expansion crisis was merely the beginning of a series of discoveries that would force scientists to question everything they thought they knew about the cosmos. But what Webb found next seems simple by comparison. 6 impossible monsters are floating in the ancient cosmos, and they're rewriting the rules of galactic evolution. When James Webb aimed its infrared eyes toward a seemingly empty patch of sky near the Big Dipper, astronomers anticipated finding tiny baby galaxies stumbling through their first billion years of existence. Instead, they uncovered 6 massive, mature star systems that shouldn't have had time to grow so large. These galactic giants contain nearly as many stars as our own Milky Way, but they formed when the universe was only 3% of its present age. Picture trying to grow a full-sized oak tree in just 3 months. That's essentially what these galaxies achieved on a cosmic scale. Star formation takes time. Gravity requires millions of years to pull together enough gas and dust to ignite nuclear fusion. Yet, these 6 systems somehow fast-tracked their evolution, becoming galactic titans while the universe was still in its cosmic infancy. The discovery occurred almost by accident. Astrophysicist Erica Nelson was examining postage stamp-sized sections of Webb's deep field images when she noticed several fuzzy red dots that appeared impossibly bright. Red light in astronomy usually signifies old light stretched by the universe's expansion during its long journey to Earth. But these objects were both ancient and blindingly luminous, a combination that defied logic. Each of these monster galaxies contains between 10 billion and 100 billion stars. To reach such enormous sizes so quickly, they would have needed to form hundreds of new stars every single year for hundreds of millions of years. Our Milky Way, by comparison, produces only about 2 new stars annually. These ancient systems were stellar factories operating at production rates that modern physics says should be impossible. The team has informally dubbed these objects universe breakers because they threaten to disrupt our understanding of how cosmic structures form. According to every simulation and model scientists have developed, matter in the early universe should have clumped together slowly and methodically. Small structures would gradually merge to form larger ones over billions of years. These 6 galaxies discard that entire timeline. They imply that the early universe was capable of organization and complexity that cosmologists never imagined feasible. Either there's a completely unknown mechanism for rapid galaxy formation, or our fundamental assumptions about cosmic evolution are catastrophically flawed. The discovery raises alarming questions about dark matter's role in early cosmic development. If galaxies could grow this massive, this swiftly, it indicates dark matter was clumping together and attracting regular matter at rates far exceeding current predictions. The invisible scaffolding that shapes our universe might be far more violent and unpredictable than we realized. Joel Leja, one of the astronomers studying these objects, captured the magnitude of the problem perfectly. We examined the very early universe for the first time and uncovered something so unexpected that it creates genuine problems for science. But confirming whether these are real galaxies will require additional observations with Webb spectrograph. And what those follow-up studies revealed would prove even more unsettling than anyone anticipated. A monster with the mass of 50 million suns is drifting through space entirely alone, and it's rewriting the history of the cosmos. Deep in the early universe, James Webb discovered something that shouldn't exist according to every theory of black hole formation. Kusun is a supermassive black hole with virtually no galaxies surrounding it. It's essentially naked, wandering through space without the usual host of billions of stars that normally accompany such massive objects. Most supermassive black holes reside at the centers of galaxies like cosmic anchors surrounded by spinning disks of stars, gas, and dust. They form a symbiotic relationship with their galactic hosts, growing together over billions of years through a delicate dance of gravity and star formation. Kusun breaks all those rules. This cosmic wanderer contains enough mass to equal 50 million of our suns, compressed into a region smaller than our solar system. To put that in perspective, if Earth were the size of a marble, Kusun would still be invisible to the naked eye while containing more matter than exists in hundreds of billions of normal stars. What makes this discovery truly disturbing is the timing. Kusun exists in the universe's infancy, just 600 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which means waiting for the first generation of stars to form, live their lives, and explode in spectacular supernovas. That process should take far longer than 600 million years. Roberto Maiolino, the Cambridge astrophysicist who helped identify Kusun, described the find as completely off the scale. The object challenges every model scientists have created for how supermassive black holes grow and evolve in the early universe. 3 theories attempt to explain Kusun's existence, and each one is more unsettling than the last. The first proposes that some black holes form directly from the collapse of massive gas clouds, bypassing the stellar phase entirely. The second suggests that intermediate mass black holes somehow grew at impossible rates by consuming matter faster than physics should permit. The third theory is the most alarming of all. Kusun might be a primordial black hole created in the universe's first seconds during violent fluctuations in space and time immediately after the Big Bang. If true, it means Kusun has been lurking in the cosmic darkness since the very beginning, waiting 13 billion years for stars and galaxies to emerge and illuminate its presence. Kusun is one of hundreds of similar objects that Webb has identified. These tiny red dots appear throughout the early universe, each one a potential cosmic monster that defies explanation. They glow with the light of matter being shredded and superheated as it spirals into their gravitational maws. The existence of these naked black holes suggests that the early universe was far more chaotic and violent than cosmologists ever imagined. Instead of the gradual, orderly formation of cosmic structures, we might be observing evidence of primordial catastrophes that forged massive black holes before the first stars even existed. If Kusun really is a primordial black hole, it represents something far more ancient and alien than any galaxy or star. But Kusun wasn't the only impossible black hole that Webb would discover lurking in the cosmic deep. Black holes older than the first stars are lighting up the universe, and they might have existed since the moment of creation. Scientists have long assumed that supermassive black holes formed after the first generation of massive stars collapsed in spectacular deaths. This process should take hundreds of millions of years. As gravity gradually pulls together enough matter to ignite nuclear fusion, stars live their brief but brilliant lives and then explode in supernovas that leave behind stellar remnants. But James Webb has found evidence of supermassive black holes existing when the universe was barely 400 million years old. Far too early for this traditional formation process to work. Andrea Ferrara and his team at the Superior Normal School in Pisa, Italy, propose a radical solution to this cosmic puzzle. What if black holes, not stars, were the first significant sources of light in the universe? What if primordial black holes formed in the chaotic first seconds after the Big Bang were already lurking in the darkness when the cosmos was still in its infancy? These hypothetical primordial black holes would have formed through a completely different mechanism than stellar black holes. Instead of collapsing stars, they emerged from extreme density fluctuations in the primordial soup that existed less than 5 seconds after the Big Bang. Picture the early universe as a violently boiling cauldron of energy and matter, with some regions becoming so dense that they collapse directly into black holes without ever forming stars. The evidence Webb has collected supports this bizarre scenario. Many of the luminous objects in the early universe appear point-like rather than extended, suggesting they're powered by compact sources rather than distributed star formation. When gas approaches a black hole, it heats to scorching temperatures and emits brilliant light. From a distance, this superheated matter can appear almost identical to the light from stars. If this theory is correct, it implies primordial black holes were feeding on the universe's first gas clouds, growing larger and more massive while simultaneously illuminating the cosmos. These monsters would have been sitting in the dark for hundreds of millions of years, essentially waiting for the universe to evolve enough to supply them with nourishment. The implications are staggering. Primordial black holes could explain how supermassive black holes grew so massive so quickly in the early universe. They had a head start of hundreds of millions of years, allowing them to reach enormous sizes before the first galaxies even began to form around them. But this scenario raises even more alarming questions. If primordial black holes were common in the early universe, they might still exist today, invisible and undetected. Some could be wandering through our own galaxy, ancient relics from the universe's violent birth that predate every star we can see. These primordial monsters signify a fundamental shift in our comprehension of cosmic evolution. Instead of a universe that gradually built complexity from simple beginnings, we might be observing a cosmos that was born with powerful, massive objects already embedded in its framework. The detection of primordial black holes would also provide critical insights into the physics of the Big Bang itself, revealing conditions in the universe's first moments that we can barely conceive. But Webb's surveys of these ancient black holes revealed an even stranger phenomenon that challenges our grasp of gravity itself. Two galaxies are colliding in a cosmic train wreck that's generating physics we've never encountered before. When astronomers first noticed the object they dubbed the Infinity Galaxy, its shape immediately captured their attention. This cosmic oddity exhibits two compact red nuclei, each surrounded by glowing rings, forming a perfect figure-8 pattern reminiscent of the mathematical symbol for infinity. But the galaxy's unusual form was just the beginning of its mysteries. The Infinity Galaxy emerged when two massive disk galaxies collided head-on in a cosmic crash that began millions of years ago. Galaxy collisions aren't uncommon in the universe, but this particular smash-up has created something unprecedented. Instead of the typical chaotic merger that destroys both original structures, these two galaxies have preserved their individual identities while producing something entirely new. What makes this collision truly bizarre is the position of the supermassive black hole. In standard galaxy mergers, the central black holes from both galaxies eventually spiral toward each other, either merging into a single massive object or ejecting one from the system entirely. The Infinity Galaxy defies this pattern entirely. The supermassive black hole rests directly between the two galactic nuclei, suspended in a vast expanse of glowing hydrogen gas stripped from both galaxies during their collision. This location should be gravitationally unstable. The black hole should be pulled toward one nucleus or the other, not floating in the center like a cosmic referee overseeing the galactic crash. Peter Van Dokkum and Gabriel Brahma, the astronomers who discovered this system, believe they are witnessing a phenomenon called direct collapse black hole formation. Instead of forming from the death of massive stars, this black hole might have formed directly from the collapse of a massive gas cloud created during the galaxy collision. The process works like this. When the two galaxies crashed together, they produced enormous streams of gas flowing between their cores. Under exactly the right conditions, these gas streams can become so massive and dense that they collapse directly into a black hole without ever forming stars. It's like watching a cosmic avalanche so powerful, it creates its own gravitational trap. This direct collapse mechanism could explain one of the most puzzling discoveries Webb has made in the early universe. The telescope has detected supermassive black holes that are far too massive for their age, growing to enormous sizes faster than traditional formation models allow. If black holes can form directly from collapsing gas clouds, they could reach supermassive status far more quickly than previously believed. The Infinity Galaxy represents a real-time laboratory for examining this exotic formation process. The black hole seems to be actively feeding on the gas streaming between the two galactic cores, growing larger as the collision continues. Radio observations reveal intense energy emissions from exactly where the black hole should be located, confirming that it's actively consuming matter. But the most alarming aspect of the Infinity Galaxy collision isn't what we can observe now. It's what this discovery implies about the violent processes that shaped the early universe. If direct collapse black hole formation was common during the cosmos's youth, it suggests the universe experienced a phase of immense violence and chaos that we're only beginning to understand. And that chaos left behind objects even stranger than wandering black holes. Hundreds of orphaned worlds are drifting through space in pairs, and they are emitting radio signals that shouldn't exist. James Webb has identified over 500 free-floating planets in the Orion Nebula that orbit no star. These cosmic wanderers, each roughly the size of Jupiter, were ejected from their original solar systems and now drift through the cold void of interstellar space. What makes them truly strange is that many travel in pairs, orbiting each other at distances ranging from 25 to 400 times the distance between Earth and the Sun. Scientists call these paired wanderers Jupiter Mass Binary Objects, or JMBOS. They defy every theory of planet formation we've developed. Planets normally form in disks of gas and dust surrounding young stars, slowly accumulating material until reaching their final size. The gravitational interplay required to create binary planets should be extremely rare. Yet, Webb has identified dozens of these cosmic couples. The mystery intensified when astronomers aimed radio telescopes at these paired planets and detected something unprecedented. Several JMBOs are emitting radio signals with patterns never observed from planets before. These aren't the typical emissions expected from worlds with magnetic fields interacting with charged particles. They're producing gigahertz frequency radio bursts, thousands of times higher than FM radio signals. On Earth, radio signals at these frequencies come from technological sources or highly energetic astronomical phenomena like pulsars and quasars. Detecting them from rogue planets implies these worlds are experiencing physical processes absent anywhere else in our solar system. The radio emissions appear linked to the binary nature of these planets. When two massive objects orbit each other, they create complex gravitational interactions that generate strong magnetic fields and electrical currents. Think of it as cosmic friction on a scale we've never encountered. The JMBOs are effectively giant electrical generators powered by their orbital dance. Yet the signals remain deeply perplexing. Different pairs of JMBOs emit different radio signatures, suggesting that each binary system has a unique electromagnetic personality. Some release steady streams of radio waves, while others produce sporadic bursts that follow no obvious pattern. The implications are alarming. If these orphaned worlds can generate radio signals this powerful, what else might they be capable of? Their magnetic fields could be far stronger than anything seen in our solar system, producing space weather phenomena that might affect nearby star systems. Even more unsettling is what the existence of so many JMBOs indicates about planetary system formation. If hundreds of these paired worlds exist in one nebula, there could be millions or billions scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational interactions went wrong and ejected planets into the eternal void. These rogue worlds are cosmic orphans, forever separated from the warmth and energy of stellar companionship. They exist in perpetual darkness, with heat coming only from the slow decay of radioactive elements in their cores and tidal forces generated by their orbital dance with their companion. But as strange as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more profound ways. The next discovery would force scientists to rethink everything they believed about how planets form around young stars. A young star system is defying the basic rules of planet formation by producing worlds made of unexpected materials. In the star-forming region NGC 6357, James Webb detected a planet-forming disk containing almost no water, but rich in carbon dioxide, precisely where Earth-like planets would normally form. This finding undermines one of the most fundamental assumptions about how rocky planets develop around young stars. Every planetary formation model assumes that regions around young stars where rocky planets form should be dominated by water, ice, and silicate minerals. Water is one of the most abundant molecules in the universe, and its presence in planetary disks is considered essential for producing worlds that could potentially support life. The disk around the star ZUI-10 overturns all of these assumptions. When Webb analyzed this system using its near-infrared spectrograph, astronomers expected to detect the familiar signature of water vapor mixed with other common compounds. Instead, they found a disk where carbon dioxide dominates the inner regions where terrestrial planets typically form. Water is so scarce it is barely detectable, creating an environment unlike anything previously modeled by scientists. This discovery challenges everything we understand about planetary formation chemistry. On Earth, water played a critical role in creating our planet's geology, atmosphere, and ultimately, the conditions that allowed life to emerge. A planet forming in the XUE-10 system would develop under entirely different chemical conditions, potentially producing worlds with no analog in our solar system. Two theories attempt to explain this unusual chemistry, both with unsettling implications. The first posits that intense ultraviolet radiation from the young star itself or nearby massive stars sterilize the disk, breaking apart water molecules and expelling hydrogen, while leaving oxygen to combine with carbon. The second theory is even more troubling. The carbon dioxide dominance may result from unusual conditions in the dust grains comprising the planetary disk. Instead of being coated with water ice like grains in normal systems, these particles may be covered with carbon dioxide due to the unique environmental conditions around this young star. Either explanation suggests planetary formation can follow pathways astronomers never imagined. If ultraviolet radiation can strip water from planet-forming disks, many potentially habitable worlds may never obtain the chemical building blocks necessary to support life. The galaxy could be populated with dry, carbon dioxide-rich planets formed under conditions hostile to life chemistry. This discovery also raises questions about the diversity of planetary systems across the galaxy. If planet formation can produce dramatically different chemical environments, there could be entire classes of worlds that operate according to geological and atmospheric processes we've never observed. The XU-10 system represents a natural laboratory for studying alternative planetary formation pathways. As the planets in this system continue to evolve, they will provide insights into how worlds form when the chemical ingredients are fundamentally different from our solar system. But the unusual chemistry of planet formation was just one of many atmospheric mysteries Webb would uncover. The telescope's next target revealed a world so hostile and alien, it challenges our definition of a planetary atmosphere. A world so close to its star that its surface glows like molten metal somehow sustains an atmosphere that defies every law of planetary science. 55 Cancri E orbits its star so closely that it completes a year in just 18 Earth hours. This hellish planet is tidally locked, meaning the same side always faces its star, creating a day side hot enough to melt copper, and a night side plunged into eternal darkness. Surface temperatures exceed 4,000 degrees, sufficient to vaporize most known materials. By every rule of planetary physics, this world should have lost its atmosphere billions of years ago. James Webb detected something impossible. This hell planet not only possesses an atmosphere, but it is composed of materials that should not exist as gases at such extreme temperatures. The atmosphere appears rich in carbon monoxide and carbon dioxide, forming a thick blanket around a world that should be as airless as Mercury. The discovery emerged through precise temperature measurements using Webb's mid-infrared instrument. When astronomers measured the thermal emissions from the planet's day side, they found it cooler than anticipated. Something was blocking and redistributing the star's heat, and that something could only be an atmosphere thick enough to transport energy from the scorching day side to the frozen night side. This atmospheric circulation creates one of the most extreme weather systems ever observed. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the day side to the night side, where these materials condense and fall as molten mineral rain. The temperature difference between day and night sides should exceed 3,000 degrees. But the atmosphere somehow moderates this difference through convection currents operating under conditions no Earth-based laboratory could replicate. What makes this atmosphere truly impossible is its origin. The hell planet's atmosphere cannot be a remnant from its formation because solar winds from its nearby star would have stripped away any primordial gases within millions of years. Instead, researchers believe it is a secondary atmosphere continuously emerging from the planet's interior. Picture a world where the crust itself is boiling. Intense heat and tidal forces from the nearby star are literally cooking the planet's interior, causing carbon-rich materials deep underground to vaporize and escape through volcanic outgassing. The atmosphere is constantly destroyed by stellar radiation and continually replenished by geological processes operating at temperatures that would vaporize most known materials. This creates a hellish cycle where the planet's interior sustains its impossible atmosphere. Rock vapor rises from the surface, is blown around the planet by supersonic winds like condenses on the night side, and rains back as molten metal and stone. The entire world has become a massive distillation apparatus operating under conditions pushing the boundaries of physics. The existence of 55 Cancri E's atmosphere indicates that planets can maintain gases under far more extreme conditions than previously thought possible. This has profound implications for understanding potentially habitable worlds. If atmospheres can survive in such hellish environments, they may also persist around planets once considered too hostile for atmospheric chemistry. But the hell planet's impossible atmosphere was only a prelude to Webb's next discovery. The telescope was about to encounter a visitor from another star system that would challenge our understanding of time itself. An ancient comet from another star system is hurtling through our solar system, and it is older than Earth, the Sun, and everything we call home. Comet 3I. Atlas appears unremarkable at first sight. It's roughly 7 miles wide, composed of ice and rock, and follows a path that will carry it past our sun before returning to the void between stars. But James Webb's detailed study revealed something that shouldn't be possible. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. When astronomers tracked the comet's steep trajectory through space, they realized it originated from the Milky Way's thick disk, a region of our galaxy packed with ancient stars that formed when the universe was much younger. This cosmic wanderer has been drifting through interstellar space since before the sun was even a glimmer in a stellar nursery. It predates Earth, Mars, Jupiter, and every planet in our neighborhood. Webb's near-infrared spectrograph revealed that the comet's coma, the cloud of gas and dust surrounding its core, is dominated by carbon dioxide rather than the water vapor typical of comets from our solar system. This unusual makeup provides clues about the chemical environment of the star system where it formed billions of years ago. The comet is traveling at over 130,000 miles per hour, fast enough to cross the entire United States in under 2 minutes. Its trajectory is unusually flat and straight, unlike anything else in our solar system. This interstellar intruder follows the gravitational rules of the galaxy rather than our sun, treating our solar system as just another obstacle to navigate around. What makes this ancient visitor truly unsettling is what it signifies. 3I Atlas is a messenger from a time when the universe was radically different from today. 7 billion years ago, the Milky Way was more chaotic and violent. Star formation rates were higher, heavy elements were rarer, and the chemical processes that build planets operated under different conditions. This comet formed around a star that lived and perished billions of years before our sun existed. It survived the death of its parent star, possibly a violent supernova explosion that obliterated its original solar system and sent it wandering through the galaxy. For 3 billion years, it journeyed through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. The fact that we're observing it now raises disturbing questions about how many other ancient visitors might be passing through our solar system unnoticed. 3I Atlas is only the third confirmed interstellar object ever discovered, but statistical models suggest that dozens or hundreds of these cosmic time travelers should cross our neighborhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. They are archaeological relics from stellar systems that existed when the universe was young, carrying information about galactic conditions from epochs no other objects can provide. But 3I Atlas also serves as a reminder of our solar system's eventual fate. In a few billion years, when our sun begins to die, objects from our world might be ejected into interstellar space, becoming ancient wanderers that will puzzle astronomers in distant galaxies long after Earth is gone. The ancient comet's visit was a preview of cosmic timescales that dwarf human understanding. But Webb surveys revealed objects even more mysterious than ancient visitors from extinct star systems. 300 enigmatic objects are glowing in the early universe, and astronomers cannot determine what they are. James Webb's deep surveys uncovered a new population of cosmic objects that don't fit into any known category. These tiny red dots appear as crimson pinpricks scattered throughout images of the early universe. But their properties are so unusual that scientists are struggling to classify them. Each one is far brighter than it should be, given what we know about galaxy and star formation in the universe's youth. The mystery begins with their color. In astronomy, red light usually indicates either extreme distance or cooler temperatures. These objects are certainly distant, existing when the universe was less than 1 billion years old. But they are also extraordinarily luminous. They produce enormous amounts of energy through unknown processes, creating a combination of traits that doesn't match any object in the modern universe. Using advanced methods like infrared imaging and spectral energy distribution analysis, astronomers at the University of Missouri identified 300 of these enigmatic objects in Webb's data. Each appears roughly the size of early galaxies, but emits far more light than galaxy formation models predict. If they are galaxies, they are unlike any that exist today. The objects are so bright that they force scientists to reconsider how galaxies could have formed in the early universe. Traditional models assume the first galaxies grew gradually, accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots suggest some process was creating massive luminous structures far more rapidly than current theories allow. But the mystery deepens further. When astronomers try to determine precisely what is producing all this light, the answers don't make sense. Some appear point-like, suggesting they may be powered by supermassive black holes rather than distributed star formation. Others show evidence of extended structure, indicating they could be genuine galaxies undergoing extraordinarily rapid star formation. The most unsettling possibility is that these objects represent an entirely unknown phase of cosmic evolution. During the universe's first billion years, physical conditions were drastically different from today. Matter was denser, dark matter interactions were more frequent, and the cosmic web of large-scale structure was still forming. Perhaps these conditions allowed types of object formation that cannot occur in the modern universe. Some of the little red dots show evidence of extremely high-energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns suggesting violent chaotic energy production. Whatever powers these objects operates under extreme conditions that push the limits of known physics. The objects also appear distributed randomly throughout space rather than clustered in regions where early galaxy formation was anticipated. This random placement suggests they may represent a fundamental property of the early universe rather than rare, isolated phenomena. Bangjong Sun, the graduate student leading the research, emphasizes that even if only a few of these objects are confirmed, they will compel scientists to revise existing theories of galaxy formation. The sheer number of mysterious objects Webb has found suggests that our understanding of cosmic evolution during the universe's youth is fundamentally incomplete. The little red dots represent perhaps the most significant challenge to cosmology Webb has discovered, but their mystery pales compared to what the telescope found when observing the large-scale structure of the universe itself. Galaxies across vast regions of space are rotating in synchronized patterns, suggesting the universe may have been born spinning. In what may be James Webb's most mind-bending discovery, astronomers found evidence that galaxies separated by millions of light years are rotating in coordinated patterns. This cosmic choreography defies our understanding of structure formation and raises the possibility that the entire cosmos was born with a preferred rotational direction. The discovery emerged from observations of 263 galaxies captured during Webb's Advanced Deep Extragalactic Survey. When astronomers analyzed the orientation and rotation of these distant star systems, they found something impossible according to standard cosmological models. Galaxies far too distant to influence each other gravitationally are spinning in similar directions. Imagine discovering that every windmill across a continent is turning exactly the same way. Even though no wind pattern could coordinate their motion, the galaxies are separated by distances so vast that light from one would take millions of years to reach another. Yet they all participate in the same cosmic dance. Leo Shamir, the computer scientist who led the analysis, proposed two possible explanations, both deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This aligns with black hole cosmology, suggesting our observable universe might be the interior of a massive black hole within a larger parent universe. If correct, the rotational patterns Webb observed could be evidence of the parent black hole spin transmitted across cosmic scales through unknown mechanisms. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest existing theories of cosmic evolution are fundamentally incomplete. Some unknown force or field must operate on scales greater than anything previously considered. The implications extend far beyond galaxy formation. A rotating universe would have different physical properties than a static cosmos described by standard models. Space and time themselves might have preferred directions, creating asymmetries in physical laws affecting everything from particle physics to the ultimate fate of the universe. The discovery also raises questions about dark energy, the mysterious force driving cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary by direction, producing a cosmos that expands faster in some directions than others. This could explain some anomalies Webb has found in cosmic expansion rates. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe spins inside a larger structure, it implies reality extends far beyond the observable cosmos. We might inhabit one component of an incomprehensibly vast multiverse, where entire universes rotate like galaxies within higher dimensional space. The coordinated galaxy rotations challenge our understanding of cosmic structure formation and the nature of space itself. But hidden rotations were only the start of Webb's assault on conventional physics. The telescope's next discovery revealed black holes forming through processes that shouldn't be possible. A supermassive black hole is forming in real time through a process that violates every rule of stellar evolution. Deep in the cosmos, James Webb observed a galactic collision creating something unprecedented. The system astronomers call the Infinity Galaxy hosts a supermassive black hole that appears to have formed through direct gravitational collapse rather than the death of massive stars. This is occurring in a location where no black hole should exist. The black hole sits suspended in a vast expanse of glowing hydrogen gas between two colliding galactic nuclei. In normal galaxy mergers, supermassive black holes from each galaxy spiral toward each other, forming binaries that merge or eject one black hole entirely. The Infinity Galaxy defies this pattern by hosting. The telescope was about to encounter a visitor from another star system that would challenge our understanding of time itself. An ancient comet from another star system is hurtling through our solar system, and it is older than Earth, the Sun, and everything we call home. Comet 3I. Atlas appears unremarkable at first sight. It's roughly 7 miles wide, composed of ice and rock, and follows a path that will carry it past our sun before returning to the void between stars. But James Webb's detailed study revealed something that shouldn't be possible. This interstellar visitor is approximately 7 billion years old, making it 3 billion years older than our entire solar system. When astronomers tracked the comet's steep trajectory through space, they realized it originated from the Milky Way's thick disk, a region of our galaxy packed with ancient stars that formed when the universe was much younger. This cosmic wanderer has been drifting through interstellar space since before the sun was even a glimmer in a stellar nursery. It predates Earth, Mars, Jupiter, and every planet in our neighborhood. Webb's near-infrared spectrograph revealed that the comet's coma, the cloud of gas and dust surrounding its core, is dominated by carbon dioxide rather than the water vapor typical of comets from our solar system. This unusual makeup provides clues about the chemical environment of the star system where it formed billions of years ago. The comet is traveling at over 130,000 miles per hour, fast enough to cross the entire United States in under 2 minutes. Its trajectory is unusually flat and straight, unlike anything else in our solar system. This interstellar intruder follows the gravitational rules of the galaxy rather than our sun, treating our solar system as just another obstacle to navigate around. What makes this ancient visitor truly unsettling is what it signifies. 3I Atlas is a messenger from a time when the universe was radically different from today. 7 billion years ago, the Milky Way was more chaotic and violent. Star formation rates were higher, heavy elements were rarer, and the chemical processes that build planets operated under different conditions. This comet formed around a star that lived and perished billions of years before our sun existed. It survived the death of its parent star, possibly a violent supernova explosion that obliterated its original solar system and sent it wandering through the galaxy. For 3 billion years, it journeyed through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. The fact that we're observing it now raises disturbing questions about how many other ancient visitors might be passing through our solar system unnoticed. 3I Atlas is only the third confirmed interstellar object ever discovered, but statistical models suggest that dozens or hundreds of these cosmic time travelers should cross our neighborhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. They are archaeological relics from stellar systems that existed when the universe was young. carrying information about galactic conditions from epochs no other objects can provide. But 3i Atlas also serves as a reminder of our solar system's eventual fate. In a few billion years, when our sun begins to die, objects from our world might be ejected into interstellar space, becoming ancient wanderers that will puzzle astronomers in distant galaxies long after Earth is gone. The ancient comet's visit was a preview of cosmic timescales that dwarf human understanding. But Webb surveys revealed objects even more mysterious than ancient visitors from extinct star systems. 300 enigmatic objects are glowing in the early universe, and astronomers cannot determine what they are. James Webb's deep surveys uncovered a new population of cosmic objects that don't fit into any known category. These tiny red dots appear as crimson pinpricks scattered throughout images of the early universe. But their properties are so unusual that scientists are struggling to classify them. Each one is far brighter than it should be, given what we know about galaxy and star formation in the universe's youth. The mystery begins with their color. In astronomy, red light usually indicates either extreme distance or cooler temperatures. These objects are certainly distant, existing when the universe was less than 1 billion years old. But they are also extraordinarily luminous. They produce enormous amounts of energy through unknown processes, creating a combination of traits that doesn't match any object in the modern universe. Using advanced methods like infrared imaging and spectral energy distribution analysis, astronomers at the University of Missouri identified 300 of these enigmatic objects in Webb's data. Each appears roughly the size of early galaxies, but emits far more light than galaxy formation models predict. If they are galaxies, they are unlike any that exist today. The objects are so bright that they force scientists to reconsider how galaxies could have formed in the early universe. Traditional models assume the first galaxies grew gradually, accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots suggest some process was creating massive luminous structures far more rapidly than current theories allow. But the mystery deepens further. When astronomers try to determine precisely what is producing all this light, the answers don't make sense. Some appear point-like, suggesting they may be powered by supermassive black holes rather than distributed star formation. Others show evidence of extended structure, indicating they could be genuine galaxies undergoing extraordinarily rapid star formation. The most unsettling possibility is that these objects represent an entirely unknown phase of cosmic evolution. During the universe's first billion years, physical conditions were drastically different from today. Matter was denser, dark matter interactions were more frequent, and the cosmic web of large-scale structure was still forming. Perhaps these conditions allowed types of object formation that cannot occur in the modern universe. Some of the little red dots show evidence of extremely high-energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns suggesting violent chaotic energy production. Whatever powers these objects operates under extreme conditions that push the limits of known physics. The objects also appear distributed randomly throughout space rather than clustered in regions where early galaxy formation was anticipated. This random placement suggests they may represent a fundamental property of the early universe rather than rare, isolated phenomena. Bangjong Sun, the graduate student leading the research, emphasizes that even if only a few of these objects are confirmed, they will compel scientists to revise existing theories of galaxy formation. The sheer number of mysterious objects Webb has found suggests that our understanding of cosmic evolution during the universe's youth is fundamentally incomplete. The little red dots represent perhaps the most significant challenge to cosmology Webb has discovered, but their mystery pales compared to what the telescope found when observing the large-scale structure of the universe itself. Galaxies across vast regions of space are rotating in synchronized patterns, suggesting the universe may have been born spinning. In what may be James Webb's most mind-bending discovery, astronomers found evidence that galaxies separated by millions of light years are rotating in coordinated patterns. This cosmic choreography defies our understanding of structure formation and raises the possibility that the entire cosmos was born with a preferred rotational direction. The discovery emerged from observations of 263 galaxies captured during Webb's advanced deep extragalactic survey. When astronomers analyzed the orientation and rotation of these distant star systems, they found something impossible according to standard cosmological models. Galaxies far too distant to influence each other gravitationally are spinning in similar directions. Imagine discovering that every windmill across a continent is turning exactly the same way. Even though no wind pattern could coordinate their motion, the galaxies are separated by distances so vast that light from one would take millions of years to reach another. Yet they all participate in the same cosmic dance. Leo Shamir, the computer scientist who led the analysis, proposed two possible explanations, both deeply unsettling. The first is that the universe was born rotating. If the Big Bang itself had angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This aligns with black hole cosmology, suggesting our observable universe might be the interior of a massive black hole within a larger parent universe. If correct, the rotational patterns Webb observed could be evidence of the parent black hole spin transmitted across cosmic scales through unknown mechanisms. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest existing theories of cosmic evolution are fundamentally incomplete. Some unknown force or field must operate on scales greater than anything previously considered. The implications extend far beyond galaxy formation. A rotating universe would have different physical properties than a static cosmos described by standard models. Space and time themselves might have preferred directions, creating asymmetries in physical laws affecting everything from particle physics to the ultimate fate of the universe. The discovery also raises questions about dark energy, the mysterious force driving cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary by direction, producing a cosmos that expands faster in some directions than others. This could explain some anomalies Webb has found in cosmic expansion rates. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe spins inside a larger structure, it implies reality extends far beyond the observable cosmos. We might inhabit one component of an incomprehensibly vast multiverse, where entire universes rotate like galaxies within higher dimensional space. The coordinated galaxy rotations challenge our understanding of cosmic structure formation and the nature of space itself. But hidden rotations were only the start of Webb's assault on conventional physics. The telescope's next discovery revealed black holes forming through processes that shouldn't be possible. A supermassive black hole is forming in real time through a process that violates every rule of stellar evolution. Deep in the cosmos, James Webb observed a galactic collision creating something unprecedented. The system astronomers call the Infinity Galaxy hosts a supermassive black hole that appears to have formed through direct gravitational collapse rather than the death of massive stars. This is occurring in a location where no black hole should exist. The black hole sits suspended in a vast expanse of glowing hydrogen gas between two colliding galactic nuclei. In normal galaxy mergers, supermassive black holes from each galaxy spiral toward each other, forming binaries that merge or eject one black hole entirely. The Infinity Galaxy defies this pattern by hosting black holes and Sleeping Beauty galaxies. What makes this black hole's feeding frenzy especially alarming are the consequences for its growth speed at such extreme accretion levels. Li 568 may have acquired most of its current mass in a single burst of rapid devouring. The black hole appears to be undergoing what scientists call a feeding episode, consuming tremendous quantities of matter in a relatively short cosmic interval. The object lies just 1.5 billion years after the Big Bang, when the universe was still in its early childhood. For a black hole to reach gigantic proportions so quickly while staying within typical feeding limits would require starting from impossibly massive seed cores. Li 568's furious consumption rate offers one possible key to this cosmic timing mystery. The speed and amount of material circling the black hole suggests that huge portions of its growth happen during similar violent episodes. These are not gradual accretion events stretched across billions of years, but intense consumption bursts that can multiply a black hole's mass by extraordinary factors in cosmic eye blinks. The physics of such extreme feasting remains largely unknown. Somehow the black hole stabilizes the accretion despite radiation forces that should blow away its supply of matter. Either the black hole has developed a way to manage radiation pressure, or the nearby material has unusual traits that allow it to resist expulsion. Li 568 represents the extreme end of black hole nourishment, functioning under conditions that stretch the laws of physics to their boundaries. The discovery implies that the early cosmos hosted devouring events far more explosive and fast-paced than anything seen in today's universe. These quick-feeding monsters could explain how supermassive black holes expanded to immense sizes so rapidly in cosmic history. Instead of slow, steady growth across eons, they endured brief but powerful consumption episodes that magnified their mass by factors of 10 or beyond. Yet Li 568's impossible feeding speed was only one instance of the bizarre behavior Webb recorded throughout the early cosmos. The telescope's surveys showed that the universe's youth was far more disorderly and violent than anyone had predicted. Colossal galaxies stand dead and silent in sectors of space where they should be blazing with newborn stars, and astronomers remain puzzled over why they stopped building. James Webb uncovered what researchers now label sleeping beauty galaxies scattered throughout the early universe. These massive stellar systems mysteriously halted their star-creating processes precisely when they should have been at peak activity. They contain billions of stars, yet display no evidence of forming new ones, contradicting every model of galaxy growth during their youth. The revelation came when astronomers studied galaxies that emerged between 600 million and 6 billion years after the Big Bang. In this era, the cosmos was filled with gas and dark matter, providing ideal fuel for rapid star formation. Most galaxies of that age should be glowing with newborn stars, consuming available gas at breakneck rates to expand their stellar populations. Instead, Webb found numerous giant galaxies that appear to have drifted into cosmic hibernation. These systems hold stellar masses comparable to our Milky Way, yet show none of the vigorous activity expected from young galaxies. They resemble enormous cities where construction suddenly halted for no clear reason. The Sleeping Beauty title arises from their dormant state during what should have been their most energetic phase. Like the fairy tale princess who fell into enchanted slumber, these galaxies stopped growing right at the height of development. But unlike the fairy tale, no obvious cause exists for their cosmic sleep. Several theories attempt to explain this unusual phenomenon, each one testing core assumptions about galaxy evolution. One possibility is that supermassive black holes at their centers became hyperactive, with energy output heating surrounding gas so hot that stars could no longer form. This process, called active galactic nucleus feedback, can shut down star creation across whole galaxies. But the timing doesn't match. The Sleeping Beauties appear to have shut down before their black holes grew active enough to produce such widespread heating. Another idea is that these galaxies burned through gas supplies so quickly during an initial burst of star creation that they essentially ran out of fuel. This would require star-forming rates far higher than models allow, implying early galaxies may have been far more efficient builders of stars than modern ones. The most unsettling possibility is that the Sleeping Beauty galaxies encountered some unknown process absent in today's universe. The early cosmos had different physical conditions, denser matter and altered dark matter structures. Perhaps those conditions permitted shutdown mechanisms we have never seen before. The presence of dormant galaxies in the early universe carries profound consequences for our grasp of cosmic growth. If giant galaxies could stop evolving so early, it suggests galaxy formation is vastly more complicated and unpredictable than we assumed. These cosmic sleeping beauties serve as haunting reminders that the early universe was far stranger, harsher, and more unpredictable than models have dared to predict. Rogue worlds, cosmic owls, and vanishing planets. A rogue planet adrift in interstellar space has developed the strangest atmosphere ever observed, with distinct cloud layers made of iron and magnesium minerals. Known as SO136 plus 0933, this cosmic wanderer bears no resemblance to any planet in our solar system. It does not orbit a star, but drifts freely across the galaxy, lit only by the faint glow of its internal heat. James Webb's atmospheric readings revealed something astonishing. This lonely planet carries a stacked atmosphere where iron rain falls through clouds composed of magnesium minerals. The result is a cosmic layer cake, with different metallic clouds arranged at varying altitudes. Near the surface lies a dense stratum of iron vapor, forming weather unlike anything on Earth. These are not gentle wisps of water vapor, but thick metallic concentrations that condense and pour down as liquid iron rain during massive storms. Higher up, another cloud layer emerges, made of forsterite, a magnesium-rich mineral often found in meteorites, forming its own unique weather cycle. The interaction between the two layers produces atmospheric dynamics that push the limits of planetary science. Webb's infrared data showed that both layers are patchy, shifting constantly, with active weather systems powered by the planet's rotation and interior heat. The iron clouds swirl differently than the magnesium clouds, weaving a three-dimensional atmospheric system that changes dramatically across the globe. Stranger still, high above both layers, Webb detected hotspots, regions of intense heat powered by radio auroras, phenomena akin to Earth's northern lights, but magnitudes stronger, lethal to any known form of life. These auroras reveal that SIMP Euro 136 possesses an immense magnetic field, stronger than anything within our solar system. This field interacts with charged particles drifting through interstellar space, creating vast currents that heat portions of the atmosphere to scorching temperatures above the metallic cloud decks. Alison McCarthy, the graduate student leading the research, described the planet as a natural laboratory of variability processes once theorized, but never directly seen. The strange interplay between iron rain, magnesium clouds, and violent auroras produces an atmospheric system unlike any other, operating under principles we are only beginning to grasp. The very existence of such chemistry on a wandering planet suggests rogue worlds may host far richer weather systems than previously believed. If one drifting world can form metallic clouds and iron rain, there may be countless others across the galaxy, each carrying unique alien skies. This iron rain wanderer represents a new category of atmosphere, rewriting the rules of planetary weather. Yet even that pales compared to the sight of a bizarre galaxy swimming through deep space, nicknamed the Cosmic Owl. At first glance, Webb's image revealed a galaxy whose glowing core resembled a pair of bright eyes, framed by arcs of gas and dust forming the outline of a face. But beneath its whimsical appearance lay something far more violent. The Cosmic Owl is part of a class known as jellyfish galaxies, which appear to trail vast tentacles of gas and stars as they move. These trailing arms are not harmless. They are the aftermath of ram pressure stripping, a brutal process where motion through superheated gas filling galaxy clusters creates a cosmic headwind that blows matter away. Imagine driving a car with loose cargo in the back. At highway speeds, the wind strips it all away. The Cosmic Owl is losing pieces of itself as it plunges forward. Webb's powerful eyes revealed that its tentacles stretch hundreds of thousands of light years, containing billions of stars ripped from their original homes. These stars, now cosmic refugees, drift in isolation within the tentacles, slowly dispersing into the darkness. Even more unsettling, this violence shows how extreme galactic environments truly are. The pressure needed to strip an entire galaxy suggests that clusters are not serene, but boiling, hostile seas of matter. Instead of drifting peacefully, galaxies are forced to fight for survival. Yet amid destruction comes creation. The stripping compresses gas, sparking bursts of new star formation within the tentacles. Webb's view revealed young, bright stars glowing blue within the owl's extended arms. Incredibly, this galaxy is being torn apart and simultaneously giving birth to new generations of stars in its wake. The owl is both a victim and a creator, its destruction fueling the birth of something new. Webb's discovery shows that galactic cannibalism and stripping are far more common than thought. The cosmos may be littered with stellar orphans, scattered far from the homes that once birthed them. But Webb's revelations go deeper, down to the level of chemistry itself. Young stars across the early universe are somehow creating heavy elements that should not exist yet. Webb uncovered infant galaxies rich in oxygen, carbon, and nitrogen at levels far beyond what stellar evolution allows for their age. By every model, such metallicity, the abundance of elements heavier than hydrogen and helium, should take billions of years through countless generations of star birth and supernova death. Yet galaxies less than a billion years old are already chemically mature. The most shocking case is galaxy JWST 131, observed just 330 million years after the Big Bang, yet producing heavy elements at a scale we never anticipated. This means either the first stars were far larger and more short-lived than expected, exploding as hypernovae that seeded their surroundings almost instantly, or some unknown process enriched the young universe with heavy elements outside of normal stellar nucleosynthesis. If so, then chemical evolution, the very foundation of cosmic history, needs rewriting. These discoveries carry profound implications. If metals appeared earlier, then rocky planets and even life-building molecules may have arisen sooner than anyone imagined. And then came the strangest discovery of all, something appearing and disappearing in our own cosmic neighborhood. Webb detected what looked like a Neptune-sized planet orbiting Alpha Centauri A, the closest star to Earth. The signal indicated a world possibly within the habitable zone, a stunning find. But when astronomers turned Webb back for confirmation, the planet was gone. It had vanished as though it never existed. Explanations range from bizarre to unsettling. Perhaps the planet has an extremely stretched orbit, visible only when it swings close, but such an orbit would be unstable, disrupted by Alpha Centauri B. Another idea is that the planet exists but is cloaked in a variable dust cloud, making it appear and vanish like a cosmic mirage. Or perhaps it is not a planet at all, but a forming world, one that flickers in and out of Webb's view as it gathers matter. The most disturbing possibility is that it is something entirely unknown, a dense cloud, a failed star, or a phenomenon without precedent. The Alpha Centauri Vanishing Act reminds us that even at the doorstep of our cosmic home, space continues to defy every expectation. James Webb has detected evidence of magnetic fields stretching across the largest structures in the cosmos, forming patterns of connectivity that eerily resemble neural networks in human brains. These primordial magnetic fields appear to be remnants from the universe's first billion years, when cosmic structure was still forming through processes we barely understand. The discovery came from Webb's observations of the cosmic web, the immense network of filaments and voids organizing matter on the largest scales between galaxies and galaxy clusters. Thin streams of gas and dark matter create bridges spanning hundreds of millions of light years. Webb found that these cosmic filaments are threaded with magnetic fields of extraordinary complexity. The magnetic patterns show an organization level that shouldn't exist in the early universe. Instead of simple, uniform fields, Webb detected intricate networks with nodes, connections, and hierarchical structures mirroring the topology of biological neural networks. The similarity is so striking that researchers are applying the same mathematical tools developed to study brain connectivity to analyze cosmic magnetism. These ancient magnetic fields raise fundamental questions about cosmic evolution. Standard models assume magnetic fields develop gradually as galaxies and stars form, with stellar winds and supernovae creating and amplifying magnetic structures over billions of years. The primordial fields Webb discovered seem to predate this process entirely. The fields show evidence of influencing early galaxy formation in ways current theories don't predict. Magnetic pressure and reconnection events might have shaped how gas collapsed into the first stars, affecting stellar masses, formation rates, and early chemical evolution. Perhaps most unsettling is what these magnetic networks suggest about cosmic structure formation. The brain-like patterns indicate the universe developed organizational complexity far earlier than scientists believed possible. Instead of simple gravitational collapse forming cosmic structures, the early cosmos might have operated more like a vast information processing system. The magnetic networks also appear dynamic, with connections forming and breaking over cosmic time. Webb detected evidence of magnetic storms spanning entire galaxy clusters, events that could impact star formation and galactic evolution across vast regions. This discovery has implications for understanding dark matter and dark energy. Magnetic fields interact with charged particles in ways that affect how matter clumps on large scales. If primordial magnetism was more complex and powerful than assumed, it might explain discrepancies Webb has observed in cosmic structure formation. These brain-like magnetic networks challenge our understanding of how complexity emerges in the universe. If such sophisticated organization existed in the cosmic web's youth, it suggests the universe has intrinsic tendencies toward complexity previously unrecognized. These primordial fields may indicate that the universe itself has properties analogous to living systems, with information processing and organizational capabilities arising from physical processes we do not yet comprehend. A supermassive black hole at the center of our galaxy pulses with irregular rhythms, hinting at unknown physics at the edge of spacetime. Sagittarius A, the 4 million solar mass black hole at the Milky Way's core, has quietly surprised astronomers for decades. Webb's continuous monitoring revealed something unprecedented. The cosmic monster exhibits erratic brightness fluctuations, resembling a heartbeat with no discernible pattern. Using Webb's near-infrared camera, researchers observed Sagittarius A over 48 hours across multiple sessions spanning a year. What they discovered was a black hole in constant flux, its accretion disk producing a continuous yet chaotic series of brightness changes, punctuated by sudden, dramatic flares. Observations showed constantly bubbling brightness across the black hole's event horizon region. Then, without warning, massive bursts of radiation would erupt from the accretion disk before calming again. These flares appear entirely random, defying any attempt to identify patterns or periodicities. Farhad Yousafzadeh, the Northwestern University professor leading the research, described the behavior as unlike anything previously seen in supermassive black holes. The team found no patterns in activity, suggesting the processes driving these brightness changes operate under physics not fully captured by current models. Two mechanisms seem to create this cosmic heartbeat. Short-term fluctuations likely result from turbulence within the accretion disk, where magnetic field interactions compress plasma, generating temporary flashes of radiation, like cosmic lightning in the superheated gas spiraling toward the black hole's event horizon. The larger flares suggest something more dramatic. These massive brightness surges may result from entire chunks of matter crossing the black hole's photon sphere, the region where light begins orbiting the black hole before escaping or falling past the event horizon forever. The irregular nature of these events indicates that Sagittarius A is more active than previously realized. Rather than a quiet, slowly feeding monster described in textbooks, the Milky Way's central black hole exists in a constant state of low-level violence, consuming matter in unpredictable episodes. What makes this behavior deeply unsettling are the implications for black hole physics near the event horizon. The brightness fluctuations originate from regions where space and time are severely distorted by gravity, creating conditions where matter and energy behave according to principles that push general relativity to its limits. The chaotic variations suggest quantum effects may influence black hole accretion processes. Near the event horizon, the boundary between classical and quantum physics blurs, potentially producing phenomena unique to black holes. The heartbeat pattern also raises questions about what happens to information falling into black holes. If the accretion disk's behavior is truly random, it could indicate that black holes destroy information in ways that conflict with fundamental principles of quantum mechanics. Sagittarius A*'s irregular pulsing provides our closest view of physics under the universe's most extreme conditions, where gravity becomes so strong that space and time themselves begin to break down. Invisible forces are reshaping cosmic structure through violent processes that leave galaxies shredded and scattered across millions of light years. Webb has uncovered evidence that dark matter, the mysterious substance comprising 85% of all matter in the universe, participates in violent interactions capable of tearing apart galaxies and reshaping cosmic structure on vast scales. These dark matter catastrophes operate through mechanisms invisible except for their devastating effects on normal matter. The evidence comes from Webb's observations of galaxy clusters, regions where hundreds of galaxies are bound by massive dark matter concentrations. When these cosmic cities collide, they produce some of the universe's most energetic events, releasing energies comparable to billions of supernovae. Webb's imaging reveals that the violence extends far beyond visible collision zones. Galaxies located millions of light years from cluster collisions show signs of violent disruption by gravitational forces, explained only by dark matter interactions on unimaginable scales. The telescope detected extensive streams of stars and gas connecting galaxies across vast distances, forming bridge-like structures spanning separate systems. These stellar streams are remnants of galaxies gravitationally shredded by dark matter during cluster interactions. What makes this cosmic violence especially disturbing is its hidden nature. Normal matter interactions create visible fireworks via electromagnetic radiation, but dark matter collisions produce no light, heat, or electromagnetic signals. The only evidence comes from their gravitational effects on observable matter. Webb's infrared sensitivity revealed the full extent of this dark violence. Faint stellar streams and tidal tails stretching millions of light years around clusters, forming vast spiderwebs of disrupted matter undetectable by previous telescopes. Each stream represents a galaxy partially or fully destroyed by dark matter. The scale of this destruction suggests dark matter is not merely passive scaffolding, but actively reshapes the universe through violent processes that eject galaxies from host clusters, strip gas, and scatter stars across intergalactic space. Simulations show these violent events might be fundamental to cosmic evolution. Dark matter particles can collide and interact gravitationally, creating shockwaves, propagating through the cosmic web and influencing galaxy formation across vast regions. Perhaps most settling is what this hidden violence suggests about dark matter itself. If it participates in such energetic interactions, it might possess properties beyond simple gravity. Some models propose dark matter particles undergo phase transitions or interact through unknown forces. Widespread dark matter violence also affects galaxy evolution and cosmic structure formation. If galaxies are constantly disrupted and reformed via dark matter interactions, the universe may be far more dynamic and chaotic than models predict. These invisible catastrophes are a fundamental aspect of cosmic evolution, operating outside direct observation and shaping the universe through violence detectable only by its aftermath. A distant galaxy bends space-time so severely that it appears in multiple locations simultaneously, creating gravitational effects challenging our understanding of general relativity. Webb discovered a galaxy so massive and dense that its gravitational field produces multiple images of itself across the sky, each showing the same star system at different points in its evolution. This extreme gravitational lensing demonstrates space-time curvature at levels pushing Einstein's general relativity to its limits. Strong gravitational lensing occurs when a massive object bends space-time like a cosmic magnifying glass. Light from more distant objects follows these curved paths, producing distorted or multiple images in surprising sky locations. This particular galaxy creates lensing far beyond anything previously observed. Webb detected at least 4 separate images of the same background galaxy, each magnified differently and showing the star system at different epochs. The gravitational field is so powerful that light takes varying times to travel each path. This time delay effect lets astronomers watch the galaxy's history unfold in multiple versions simultaneously. One image shows the galaxy 800 million years ago, another 1 billion years in the past. The lensing galaxy acts as a cosmic time machine, displaying stellar evolution across multiple epochs. The discovery is disturbing because of the implied mass distribution necessary to create such extreme curvature. The galaxy must contain dark matter concentrations denser than models predict, clumped in structures challenging our understanding of how these particles organize. Instead of smooth halos, Webb detected dark matter clumps and voids, suggesting complex internal dynamics through unknown mechanisms. Time delay measurements provide observational evidence of space-time curvature following general relativity, but the extreme lensing pushes effects into regimes where quantum gravity may influence classical geometry. Perhaps most unsettling is what this implies about other extreme gravitational regions in the universe. If one galaxy can warp space-time this severely, many other regions may exist beyond our modeling ability. The multiple images also show that the lensed galaxy undergoes rapid evolution, with star formation rates changing dramatically between epochs. This provides unprecedented insight into galaxy evolution during peak activity. The time-warp galaxy serves as a natural laboratory for studying general relativity under extreme conditions, revealing how massive objects reshape the geometry of space and time. These effects operate where classical physics breaks down, potentially uncovering new aspects of cosmic structure at the interface of general relativity and quantum mechanics. Stars throughout the universe are devouring companions in feeding frenzies so violent they create entirely new cosmic explosions. Webb has captured direct evidence of stellar cannibalism, showing that binary star systems often end in catastrophic events where one star consumes its companion. These feeding events produce some of the universe's most violent explosions, generating energies that can outshine entire galaxies. The process begins when two stars orbit closely enough that their outer atmospheres start interacting. If you want, I can combine all your previous sections with this one into a single continuous, polished AI voiceover-ready script covering every cosmic phenomenon you've mentioned, from black holes to rogue planets to cosmic webs, so it flows seamlessly for narration. The more massive star gradually strips material from its companion, forming streams of superheated gas that spiral inward in brilliant accretion disks. What begins as a slow feeding process can suddenly erupt into a catastrophic consumption event. Webb's infrared vision has revealed these stellar feeding frenzies in unprecedented detail. The telescope peers through the gas and dust that normally obscure such violent interactions, showing how matter flows from victim stars to their companions in complex gravitational dances that end in cosmic cannibalism. The most extreme cases involve white dwarf stars, dense remnants of dead stars roughly the size of Earth but containing the mass of our Sun. When these cosmic vampires accrete material from companion stars, they can trigger thermonuclear explosions called type Ia supernovae, temporarily outshining billions of normal stars. Webb has discovered even more violent stellar cannibalism events involving neutron stars and black holes. When these ultra-dense objects consume companion stars, they create kilonova explosions that forge heavy elements like gold and platinum while releasing gamma-ray bursts detectable across billions of light years. The telescope has documented the full life cycle of stellar cannibalism, from the initial stages where companion stars begin losing material, through rapid accretion phases where feeding accelerates dramatically, to the final explosive events that scatter heavy elements across space. Perhaps most disturbing is how common these cosmic feeding events appear to be. Webb surveys suggest stellar cannibalism may be a fundamental driver of chemical evolution in the universe, responsible for creating and distributing many of the heavy elements essential for planet formation and potentially life. The violent nature of these events also impacts surrounding stellar nurseries. Cannibalism explosions can trigger or halt star formation across vast regions, creating feedback effects that shape galactic evolution on scales far larger than the original binary systems. Webb has also discovered evidence of failed cannibalism events, where binary systems begin the feeding process but are disrupted before reaching explosive conclusions. These cosmic near misses create exotic stellar remnants with properties unlike anything in our local galactic neighborhood. The prevalence of stellar cannibalism forces astronomers to reconsider how binary star evolution affects cosmic chemical evolution. Instead of stars living isolated lives and dying peacefully, many engage in violent feeding relationships ending in catastrophic explosions. These feeding frenzies are among the primary mechanisms through which the universe creates and distributes the heavy elements necessary for complex chemistry and potentially life. Evidence is mounting that reality itself fractures at cosmic scales, revealing fundamental cracks in the fabric of space-time that challenge our basic understanding of physics. Webb's most disturbing discovery may not be a single object, but the accumulating evidence that space-time becomes unstable under the extreme conditions found throughout the cosmos. The telescope has detected gravitational anomalies, unexplained energy signatures, and structural irregularities suggesting that the smooth fabric of space-time, described by general relativity, is more fragile than previously imagined. The evidence comes from multiple Webb surveys. Gravitational lensing around some massive objects deviates from precise realistic predictions, indicating space-time may break down under extreme gravitational stress. These anomalies appear near black holes, galaxy cluster cores, and other massive cosmic structures. Quantum mechanics predicts that spacetime at the smallest scales is foamy and chaotic, with virtual particles and energy fluctuations creating a turbulent quantum foam underlying smooth, classical geometry. Webb's observations suggest this quantum foam may bubble up to macroscopic scales under extreme conditions. The telescope has detected unexplained energy emissions from regions where quantum effects shouldn't be observable, including mysterious radiation from black hole event horizons and anomalous heating in galaxy cluster cores. These phenomena may represent quantum foam breaching classical spacetime during violent cosmic events. Perhaps most unsettling are Webb's observations of cosmic strings, hypothetical one-dimensional defects in spacetime formed during the universe's earliest moments. If they exist, these structures represent fundamental cracks in reality, places where spacetime is literally torn or folded in ways that defy our understanding of cosmic geometry. Webb has identified several candidate cosmic string signatures, including gravitational lensing patterns that cannot be explained by known matter or energy distributions. These observations suggest the universe may carry permanent scars from its violent birth, defects persisting as vulnerabilities in spacetime. The telescope has also found evidence of vacuum decay events, regions where the quantum vacuum appears to have transitioned to lower energy states, releasing enormous amounts of energy. These events could represent fundamental phase transitions in reality's structure. The accumulating evidence suggests the universe operates closer to the edge of physical stability than previously believed. Under extreme conditions involving massive gravitational fields, high energy densities, or exotic matter states, the fundamental structure of spacetime may become unstable. These quantum foam breaches have profound implications for cosmic evolution and the ultimate fate of the universe. If spacetime can become unstable under naturally occurring cosmic conditions, reality itself may be far more temporary and fragile than assumed. The detection of quantum effects on cosmic scales suggests the boundary between quantum mechanics and general relativity may be more porous than theory predicts, with implications for black holes, cosmology, and the nature of reality itself. Even more unsettling is the possibility raised by Webb's discoveries that our observable universe may exist inside a massive black hole within a larger cosmos. This black hole cosmology theory could explain several of Webb's puzzling observations, including coordinated galaxy rotations and apparent contradictions in cosmic expansion. Webb detected galaxies separated by millions of light years, spinning in coordinated directions. Impossible unless the universe has a preferred rotational axis. In black hole cosmology, this alignment results from our universe inheriting angular momentum from the parent black hole containing us. The theory posits that the Big Bang was actually our universe crossing the event horizon of a massive black hole in higher dimensional space. From inside, this crossing appears as cosmic expansion, but from the larger universe's perspective, we are falling toward the black hole singularity, taking infinite time due to gravitational time dilation. This scenario explains the accelerating expansion we attribute to dark energy. Primordial black holes detected by Webb, predating star formation, fit the black hole cosmology model, representing ancient objects from the parent universe. Coordinated galaxy spins make sense if our universe inherited rotational momentum from a spinning parent black hole. If black hole cosmology is correct, everything we observe, from the cosmic microwave background to distant galaxies, exists inside the event horizon of an incomprehensibly massive black hole. We are forever separated from the larger universe, unable to communicate or influence anything beyond our cosmic prison. The model also implies black holes throughout our universe may contain entire universes of their own, forming a nested hierarchy where each black hole hosts a complete cosmic realm with its own physics, evolution, and potentially life. This possibility transforms our understanding of cosmic significance, suggesting the universe we inhabit may be one bubble in an infinite multiverse of black hole universes. Webb's discoveries don't just challenge our understanding of the cosmos, they alter what it means to be human in a universe far stranger and more dangerous than imagined. Every assumption about galaxies, black holes, and cosmic expansion has been shattered. The universe Webb reveals is not orderly and predictable. It is violent, chaotic, and often incomprehensible. Galaxies form faster than physics allows, black holes wander naked through space, and space-time itself may be unstable. We inhabit a cosmic arena where reality can break down under extreme conditions. Perhaps most unsettling is the implication for our cosmic isolation. If we exist inside a black hole universe, we are permanently cut off from the larger reality that contains us. Every signal sent, every exploration attempted, remains trapped within our cosmic prison. The prevalence of cosmic violence also affects survival prospects. Wandering black holes, rogue planets, and stellar cannibalism events can sterilize vast regions of space. Webb's discoveries highlight how little we truly know about the cosmos. Despite centuries of progress, the telescope's first years have revealed phenomena requiring a complete reevaluation of cosmic evolution. Yet Webb's revelations also offer hope. The universe's capacity for surprise and complexity suggests evolution may be richer and more diverse than models predict. If reality can produce impossible galaxies and naked black holes, it may also create life and intelligence in ways we cannot yet imagine. Webb has shown that we are cosmic infants, living in a universe governed by principles we are only beginning to glimpse. Every impossible object and phenomenon offers an opportunity to expand our understanding of what is possible. Most importantly, Webb's discoveries remind us that the universe owes us nothing. Reality operates on its own logic, often alien to human intuition. Our survival depends on adapting our understanding to match the cosmos as it truly exists, not as we wish it were. The universe James Webb has revealed is strange, violent, and often incomprehensible, but it is the only reality we have. Understanding it, no matter how disturbing, is humanity's best hope for navigating the cosmic future that awaits.